Hello. In this video, we're going to look at some of the captures that we've already saved during the attack video. Now, we're going to look at them quickly because there's quite a lot to see, but it's the same process, and that's what's important when you are collecting the evidence and the investigation. The same process is usually what matters. So for every capture that you've taken, you should be able to collect evidence related to which interface or communication path you captured, which protocol carried the evidence, which source and destination were involved, which topic, node, or field identifies the affected assets, what was the normal traffic before, or what were the normal values before the activity, before the attack activity, what changed during the attack activity. Did normal traffic continue at the same time? This is matters for example, in availability attacks, normal traffic does not continue. Did the traffic return to normal afterwards or not? So there's a lot of things that you can look at. I'm going to focus on one example, the authenticity capture, and then I will give you quick examples of how you can look at others. For example, here we're going to open the terminal. We're going to go to desktop, SISEN, and we've captured the traffic in captures folder. So I'm going to go to Wireshark and captures, and you can see there's a lot of captured files. These are from the first activities that we captured. We're going to look now at authenticity. So I'm going to open authenticity spoof.pcap. Now what I'm going to do is, as you can see, there's a lot of different packets that are collected. Specifically, you can see that there is MQTT packet, and that's what matters because these are the packets that carry the telemetry traffic, and the spoofed one as well. So we can use the Wireshark display filter. For example, we can filter by MQTT. You can also narrow it down because there's still a lot of, as you can see, there's a lot of different packets. So we can still, narrow it down by saying, for example, MQTT that topic, and it needs to contain MQTT.topics and contains building, for example. Or we can use MQTT message type, and you can select 3, and 3 basically means it's published messages. So MQTT dot message type equals 3. So what you can do is you can look at all of those different packets, and I'm going to remove this for a second. So as you can see here, all of those messages are published messages, and to look at the value for one specific, you can just look at it, click on the MQ telemetry transfer protocol published message, and then the message itself. Now obviously this message is an ASCII code, but you can see next to it is the value which is occupied for that particular message, and you can look here at another one, and the value here is 54.85 degrees. Now, what we can do is, we can usually look at the topic. For example, we want the building humidity, or you want something else, gas leak. Let's say, for example, we're looking at particularly at building gas leak. So I'm going to right click on it, and I'm going to put apply as filter selected. So I want to see all the gas leak values that happened. Now you can choose a different attack if you want, and if you look at all of them, and you can go one by one, you can see that it's normal, all the way until you find one that changed value. And you can see here, gas detected. Now what I wanted to look at here specifically, two things first. First, the length of the message. You can see that these lengths of the messages are different than the normal ones that we are receiving when it was normal. So it's 99, 99, and then all of a sudden it's 105. And also look at the let's look at the TCP index as well. That's actually quite important. So I'm going to click on transmission control message, transmission control protocol messages, and stream index. I'm going to right click on it, and I'm going to put apply as column. Now you can see here gas leak detected and gas leak detected normal. So it keeps on changing. Now we are able to identify by this which of those messages were part of this spoofed message, because we know that during the operation of that particular attack there were no gas leak, but because there's spoofed messages that coming at the same time where the attack is happening, you can see that it's changing between normal traffic and leaked gas. Here we can see all of them are leaked during this time because we have sorted them by the time. If you go all the way up, leak normal, all the way, and then here, at some point here, leak detected, right? And if you keep on going, you will find that it went back to normal, and then it changed. This is where the attack was still happening. And this is quite important because what we're investigating in this case, we know that a gas leak didn't happen, but we can see that there are messages where the sensors were reporting that there's a gas leak, where in reality there were no gas leak. So this is one example of things that we need to look at. What's important in these cases is that you need to try to identify that the topic alone might not really distinguish between the legitimate publisher from the attacker, and the spoof method that use a trusted looking identity. So it's difficult, and in this case they're coming from the same IP address in any case. So monitoring a system that trusts the topic, you're trusting the topics that coming and payload without authenticating the provider or the publisher, is displaying false information as though they're coming from a legitimate sensor. Another example that you can look at that probably will show you a little bit more easier value to see, which is the extreme, which is the integrity extreme pcap. Again, similarly, we can filter them by basically the MQTT, or you can filter them by values of building, or by the message type published. So I'm going to try to filter them by the publish message type. So these are all published message types. Now what I'm going to do is I'm going to try to find affected topics. So for example, let's say the affected topics were targeted were temperature, or for example humidity, or gas, or air quality. So let's say for example MQTT topic, let's do this again, MQTT topic, and this time instead of building, I'm going to use occupancy, or let's say gas. Now you can see here, these are the published messages, these are the nodes, and if you look at the messages here, the message here is normal, this is normal. These are different values for different sensors in different rooms. And what we're looking here are extreme values. So I'm going to go to one that starts publishing extreme values. And you can see here that this node is now reporting random values, for example, temperature 23, and it's on the gas basically, but it's publishing the wrong messages. So the integrity of that particular one is not accurate. And then you start here seeing gas detected. Now what I want to say here is you can see that. So the stream index in this case is quite important because you can see that there are normal traffic that is happening, that you can see the TCP connections 1 and 2, and then all of a sudden there are other TCP connections happening. These are the TCP connections happening by the attacker. Now you may wonder why normal connections are still showing gas detected. That's because for the after an attack's happening, because we sorted them by time, right? It's basically still reporting gas detected. It's not having the time to change, where there's another one gas detected and the third one and so on. Only when we stop the attack that you can see it goes back to normal. So you can see that those values are quite important. What you need to inspect in those cases are to inspect normal packet with before the attack, for example. If you can go here before the attack. So here gas detected. This is where there's no gas detected. Let's see if there's so normal gas detected. Right. So if you look at gas detected here, and you look at the packet right up before it started reporting that gas detected here, and if you look at the MQTT topic, for example, the payload here, you will find that there are 3 different messages happening at the same time. There's a gas leak, where it's reporting the normal, where the gas leak is reporting normal, temperature is reporting 23.4, and another temperature is reporting as well 23.4. This is where the attack started. And you can also, so there's a lot of things you can do. For example, you can search by string, and you can say, for example, I want to find detected. So these are the messages that have gas leak detected. Or you can find, for example, frame type. This basically allows us to put the duration of repeated extreme messages. So we will find how long each of them took. And you can see here the time each message took. And these are quite important because all of these, you can start building some kind of storyline of when the attack started to when the attack finished. You can do exactly the same with replay attack. You can do exactly the same with all the other captures that we have done. So I'm going to stop the video here now. There's quite a lot of documentation on how to look at the evidence for capturing the traffic of the attack on GitHub and on SISEN.uk site. And what we're going to do is next we're going to look at the manual attack, one example of monitor mode and confidentiality attack on the wireless infrastructure. Thank you.